Okay, so this is a big moment. We are about to talk about the definitions of the nth Taylor polynomial and Maclaurin polynomial. Okay, so you just have to have a function that has n derivatives at some value c. Then this is the Taylor polynomial right here, right? It is the function at c, right? And I'm just going to add in the fact that that's the same as divided by 0 factorial times the derivative of the function evaluated at c. Again, you could add in 1 factorial times x minus c to the first. This technically has an x minus c to the 0 power, but that would just be 1, right? And so no need to write it. And then here you start to see the pattern, right? The second derivative at c divided by 2 factorial with the x minus c squared, and then so on and so forth, however far you need to go until the last one, which is the nth derivative evaluated at c divided by n factorial times x minus c to the n. All right, so that is a huge deal. Basically, what this polynomial does, right, is it approximates the f of x graph around or close to the value of the center, which is x equals c. Okay, so that's the nth Taylor polynomial for f at c. Now, there was this dude Maclaurin who's like, dude, Taylor, what you did is really cool. What if we consider just the special case when the center is 0, right? And he basically took all of Taylor stuff and threw his name on it. Maclaurin polynomials are basically exactly the same as Taylor, except the center is 0. Okay, so when I tell you something is a Maclaurin polynomial, I'm telling you the center. And so if you look, instead of having to say c all the time, it's 0. And instead of x minus c, x minus 0 is just x, right? And so you are seeing the exact same situation here. Oops, this should be a 0. As above, except everywhere you saw c, it's now a 0, and instead of an x minus c, it's just an x. Okay, so that's the nth Maclaurin polynomial for f. Okay, so this can be a little confusing. I want to go through an example with you, right? Maclaurin polynomial, as soon as you read that, right, that tells you the center is going to be 0. Okay, so basically this approximation is going to be centered around an x value of 0. And for me to make sure that I'm building it correctly, what I'm going to do is use a 3-column method, right? And my first column is always going to be the nth derivative at x. And then I'm going to worry about plugging in the center, right? So this could be just any center. For this case, I know the center is 0. And then the third column is always going to be my actual coefficients, right? Which would be the nth derivative, evaluate the center, in this case 0, divided by n factorial. And so this will tell me all of the coefficients I need for the polynomial, okay? All right, so here we go. We need the nth Maclaurin polynomial for f of x equals e to the x. So I'm going to start with no derivative. Then I'm going to take the first derivative. Hey, this is pretty good, right? This is my favorite derivative. Second derivative. Cool. Third derivative. How many of these do I need to write, you might be wondering. Great question. Basically, I could keep doing it forever, but we know this is never going to change because it's its own derivative. So the nth derivative is also e to the x. Well, that makes things a little bit easier when we're plugging in numbers as well, right? Because e to the 0 is 1, 1. So no matter which derivative I'm looking at, it's going to be 1. And then all I have to do is go ahead and divide them by the factorial. So 1 divided by 0 factorial, well, that's just 1 over 1, so 1. The next one will be 1 divided by 1 factorial, that's 1 over 1, that's 1. The next one's 1 over 2 factorial. You can call that 1/2 if you want to. I don't always see a big need to do that. I might just leave it 1 over 3 factorial, 1 over 4 factorial, so on and so forth. And then the nth term would be 1 over n factorial. So if I want to build the nth degree Taylor or Maclaurin polynomial, or Taylor polynomial centered at 0, right, it would look like this. It would be the first coefficient, so 1, times x to the 0, which is another 1, plus the next coefficient, 1 times x to the first, plus the next coefficient, 1 over 2 factorial x squared. The next coefficient, 1 over 3 factorial times x cubed. right? And I can go on, so on and so forth. And the last one would be 1 over n factorial times x to the n. And so that would be the nth degree Maclaurin polynomial for the function e to the x.